We're going to look at this function. We have fx is equal to greatest integer of cos 2 pi x plus square root of fraction part of sine pi x over 2. We have to check differentiability of this function at x is equal to 1. Here we have function involving greatest integer function and fractional part function. This is going to be very interesting one. We will first check continuity at x is equal to 1. First of all, we write fractional part of sine pi x over 2 as sine pi x over 2 minus greatest integer of sine pi x over 2. We have definition, fraction part of p is equal to p minus greatest integer of p. Okay. We have now function fx is equal to greatest integer of cos 2 pi x plus square root of sine pi x over 2 minus greatest integer of sine pi x over 2. Now what will be value of f of 1? Put here x is equal to 1. We get greatest integer of cos 2 pi plus square root of sine pi by 2 minus greatest integer of sine pi by 2. Okay. Cos 2 pi is 1, exact 1, okay, because here x is exact 1. So we have here 1, greatest integer of 1 is 1 plus square root of 1 minus 1. Okay, so we have value 1, f of 1 is 1. Okay, then we find value of f of 1 plus right hand limit of function at x is equal to 1. Value will be cos 2 pi plus square root of sine pi by 2 plus minus greatest integer of sine pi by 2 plus. What will be value of cos 2 pi plus? Value will be close to 1 but less than 1. 2 pi plus means first quadrant. Okay, angle is close to 2 pi. But more than 2 pi, value of cos will be slightly less than 1. So its greatest integer will be 0. Okay. Value of sine pi by 2 plus will be also less than 1. Sine pi by 2 is 1. But sine pi by 2 plus is slightly less than 1. So we have here 1 minus 0. Greatest integer of value slightly less than 1 is 0. So this is also 1. Similarly, value of f of 1 minus will be also 1. Okay, so function is continuous at x is equal to 1. Now we check differentiability. Okay, we will first find right hand derivative f dash 1 plus. By definition this is limit h tends to 0 of f of 1 plus h minus f of 1 over h. Okay, value of f of 1 is 1 and f of 1 plus h will be, we will have greatest integer of cos of 2 pi plus 2 pi h, okay, plus sine of pi by 2 plus pi by 2 h, in fact square root of this minus greatest integer of sine of pi by 2 plus pi by 2h. Okay, cos 2 pi plus theta is cos theta. So we will have here greatest integer of cos 2 pi h plus sine pi by 2 plus theta is cos theta. Okay, so we will have here square root of cos pi by 2h minus greatest integer of cos of pi by 2h. Okay, this minus 1, this whole divided by h. Okay, okay, now here we have h tends to 0, means h tends to 0 plus. For 0 plus this angle will be 0 plus and value of cos 0 plus is 1 minus. cos 0 is 1, but cos 0 plus is slightly less than 1, and greatest integer of value slightly less than 1 is 0. So we have here 0 plus square root of cos pi by 2h. Here angle is 0 plus, again cos 0 plus is less than 1 and its greatest integer is 0. So we have here square root of cos pi by 2h, okay, this minus 1 over h. We have limit h tends to 0, okay. Put h is equal to 0, we get root cos 0 minus 1 means 0 over 0. So this is an indeterminate form, okay. So to get the limiting value, we can use L'Hopital rule. We differentiate numerator and denominator separately. We get limit h tends to 0 of, we can also rationalize this, but let's use L'Hopital rule, okay. Derivative of this will be 1 upon 2 into root cos pi by 2h into minus pi by 2 sine pi by 2h, this over 1, okay. Now in this put h tends to 0, h is equal to 0, value will be 0, okay. Cos 0 is 1, but here we have sine pi upon 2h, so we will have sine 0 is 0, so value is 0. That means right hand derivative at 1 is 0, okay. Now we find left hand derivative. For left hand derivative f dash 1 minus, we will have limit h tends to 0 of f of 1 minus h minus f of 1 over minus h, okay. So we will have here cos 2 pi minus 2 pi h, and here we will have angle pi by 2 minus pi by 2h, okay. Now again this is cos theta, cos 2 pi h, and this is cos theta or cos pi by 2h, okay. So we will have here this over minus h, okay. And then we will use L'Hopital rule. We will get here this over minus 1. Again limiting value will be 0. So left hand derivative is also 0. Left hand derivative is equal to right hand derivative. So function is differentiable at x is equal to 1. Okay.